All right, welcome back. So I'm going to go through these starter problems as I promised. I'm going to try to squeeze them all in just in line. If I have to scroll down, I'll do that for some of them if they get a little bit longer. So here we are simplifying. That, of course, means that we need to cancel out any common factors. So number 1, 4, 6, hopefully you just see we divide those both by 2. That's 2/3. I talk about people being fraction ninjas sometimes in my HL class because you just need to be able to do everything with fractions. And if you struggle with fractions, please let me know. I'd be happy to help. You'll see in one of the worksheets the complex fractions. There's a lot of that areas for mistakes, but generally people do pretty well. The next one, I'm going to do a little factoring here. So first of all, I'm going to do a domain restriction. I know x can't be 0. X can't be 0. Right? That's our domain restriction there because if it was, then the bottom would be 0. But I'm going to factor this. I'm going to factor a 2 out of the top. We're left with 2x squared plus 3. And we got 2x on the bottom. So that 2 cancels. And we have 2x squared plus 3 over x. And that's the best we can do. Some people say, well, you could split that across the top. So you'd have 2x squared over x plus 3 over x, which is 2x plus 3 over x. I wouldn't argue. I don't think that's really that much cleaner. I prefer everything in one fraction if possible, but unless they're very specific, I would say either of those answers would be acceptable. The next one, we got a difference of squares on the top, which is a special case for factoring, but really it's not that hard. So if I set up some factors here, we're going to have x and x to get x squared. And the 4 is going to be a plus 2 and a minus 2 because I need those x's to cancel out. So the outside terms, the inside terms will go away. On the bottom, if we factor this, looks like x and x, and it's going to have to be 2 and 1, both subtracted. So our domain restrictions here, x cannot be 2 or 1. You can put them in order if you want. But if we cancel out the common factor here, we get x plus 2 over x minus 1. So the domain restrictions along with the fraction are kind of what I'm looking for an answer there. Next one, it's given in fact, is that the same answer as the last one? It totally is. All right, well, the x minus 2's cancel, so it's the same answer. X can't be 2 or 1. And the final answer is a bad not equals, sorry. The final answer is the x plus 2 over x minus 1. So we had to factor for the first one, but this was the same problem, and they just had it factored for us already. A little bit more fun here. We got an x cubed plus 27, so that's going to be an x plus 3. SOAP, same, opposite, x squared minus 3x. And the last one's always positive, and it's the square of the cube root of 27, so that's going to be a 9. Then on the bottom, x cubed minus 9x. Let's see, that's x times x squared minus 9. And x squared minus 9, I'm going to use some whiteboard trickery. That's x plus 3x minus 3. So I'm just going to get rid of that x squared minus 9 and put in an x plus 3 and an x minus 3. So domain restrictions, x can't be 0, -3, or 3. And our final answer, if we cancel out the x plus 3's, is x squared minus 3x plus 9 over x times x minus 3. There we go. Last problem here, let's see. We got an a value that's not 1. That's why this is a little bit harder. So 2x and x to make that 2x squared. -1 could only be 1 and 1. So let's see here. We want a -2x and a positive 1x. So the outside terms are -2x. The inside terms are 1x. That makes that -x. On the bottom, x plus 1, x minus 1. Not a negative. Sorry about that. X plus 1, x minus 1. Domain restrictions, x cannot be plus or minus 1. You can write it like that, actually. Plus and minus 1 not allowed, or you can, of course, write x cannot be -1 or positive 1. And then we cancel out our -1's. Our final answer is 2x plus 1 over x plus 1. That's our final answer. Cool. Hopefully you were able to get through these. Hopefully they weren't too tough. I'm going to recommend you move on to the 2 worksheets for today now, which you can find on Toddle.